Welcome to The Explainer. Today, we're diving into one of the most important ideas in AI right now, Retrieval-Augmented Generation. You've probably heard it called RAG, and honestly, it's the secret sauce that's turning AI from a cool party trick into a tool you can actually use for your work and your life. So why do we even need RAG in the first place? Well, it all boils down to this one simple, powerful idea from LangChain's Lance Merton. The giant AI models we hear about every day, they're trained on the public internet. But just think about it for a second. All of your most critical information, your company's reports, your team's chat history, your private databases, is completely invisible to them. And that really is the billion-dollar question, isn't it? How do we connect these incredible AI brains to all the private, specific knowledge they need to actually be helpful to us? Well, the answer, as you've probably guessed, is RAG. All right, so to really wrap our heads around this, we've got to first talk about the fundamental problem with these large language models, or LLMs, this kind of built-in knowledge gap they all have. And this slide just lays it all out there. On one side, you've got the LLM's brain, which has read trillions of words from the public web. It's vast, for sure, but it's also super generic. On the other side, you've got your knowledge, the stuff that's specific, private, and actually relevant to you. RAG is the bridge that connects these two worlds. Now, you might be thinking, wait a second, can't we just, stuff all of our documents into the prompt now? And yeah, it's true, these context windows, the amount of info you can feed an AI at once, have gotten huge. We're talking 1 million tokens or more, which is like thousands of pages of text. But as we're about to see, just cramming everything in there is a really messy, super expensive, and surprisingly not very effective way to solve the problem. So, if just stuffing everything into the prompt isn't the answer, what do we do? Well, this brings us to the first really big idea, a brilliantly simple process called RAG. My favorite way to think about RAG is this. It's like giving your AI a super fast, expert research assistant. Now, this assistant doesn't know everything, but they have the key to your company's private library. So when you ask a question, the assistant doesn't just guess. Nope, it sprints into the library, finds the exact right page in the exact right book, and hands just that piece of paper to the AI. That way, the AI can write a perfect, informed answer based on actual facts. And this whole process breaks down into 3 pretty simple steps. First up, you've got indexing. This is where you get your private library ready. You're building that digital card catalog to make all your data searchable. Next is retrieval. You ask a question, and the system zips through that index to find the most relevant bits and pieces of info. And finally, generation. You take those retrieved pieces, you take your original question, you bundle them all together and send them to the LLM. It then uses that specific, grounded information to write you an answer. Okay, so that basic pipeline is already pretty powerful. But, the real world is messy. So pretty quickly, the developers building these systems started asking, how can we make this whole thing a lot more intelligent? And here's the first big hurdle you run into. What happens if the user asks a kind of lousy question? It's vague, it's poorly worded. The old saying is true, garbage in, garbage out. A simple search is just going to pull back garbage results. So how does RAG get around that? The solution is actually pretty genius. You teach RAG to be a smarter question asker. Instead of just taking your query at face value, it can rewrite it from different angles, which increases the chance of getting a good hit. Or it can use something called step-back prompting to ask a broader, more general question first to get the lay of the land. There's even this wild technique called hide, where the AI generates a hypothetical, perfect answer and then searches for real documents that look like its imagined one. It's improving the question before the search even begins. Okay, so we've fixed the question. That's a huge step. But what happens when the answer isn't in a nice, neat text document? What if parts of it are in a database over here and other parts are on the live web over there? This is where the system learns to be a smart searcher. It acts like an intelligent switchboard operator. This is called routing. The RAG system looks at the question and figures out the best place to find the answer. A question about sales figures, it routes that to a SQL database. A question about what happened in the news yesterday, it routes that to a web search. It's all about sending the right question to the right tool for the job. So let's recap. We've asked a smarter question, and we've searched in the smartest place. But now we have a whole new problem. Just because we found some information, how do we know if it's any good? Some of it might be out of date or totally irrelevant or just plain wrong.
This led to the next big evolution, making RAG its own judge and jury. After retrieving a bunch of documents, an advanced system can have another AI step in and basically grade the results. Is this document actually relevant to the question? Does it even make sense? And based on those grades, it filters out all the junk, making sure only the highest quality information makes it to that final answer.
So when you start adding all these new abilities together, the smarter questioning, the smarter searching, the smarter judging, you get this huge shift in how these systems work. It's a move away from that simple pipeline to something much, much more dynamic. You know, that basic RAG we started with, it's like a one-way street. A question comes in, it goes through the steps one by one. Indexing, retrieval, generation, and an answer pops out the other end. It's a fixed, linear path. But what if, instead of a simple street, it was more like a dynamic, thinking machine? What if the path could actually stop, think, loop back on itself, and correct its own mistakes when it hits a dead end? Well, that's exactly what people are building right now. Welcome to active RAG, or sometimes it's called adaptive RAG. Instead of a one-way street, it's a reasoning loop. It retrieves a document, and then it grades its own work. If it decides the documents aren't relevant, it can use a fallback and just decide to do a web search instead. After it generates an answer, it checks it against the sources to make sure it's not making stuff up. And the best part? If any step fails, it can loop all the way back to the start, rewrite the original question, and just try the whole thing again. It's a system that truly reasons and self-corrects its way to a better answer. Okay, so with these crazy new powers, where does RAG go from here? This brings us back to those enormous context windows we talked about. Is RAG still even necessary? This gets us to that big is RAG dread debate. And the answer from all the tests people are running is a pretty firm no. It turns out that when you just stuff thousands of pages of text into a model, its accuracy really drops, especially when you ask it to reason about multiple different facts. The model just gets lost in all that noise. So that huge context window, it isn't the silver bullet we all hoped for. So RAG isn't dying, it's just evolving. The old way of doing RAG was obsessed with finding these tiny, precise little chunks of text, which was often really brittle and easy to break. The future of RAG is much more robust. Its job is to retrieve the right full documents, the whole report, the whole transcript, and then let the LLM, with its massive new context window, do the heavy lifting of reading and reasoning about them. And that really is the perfect way to wrap this all up. RAG isn't a temporary patch that's just waiting to be replaced by a bigger model. It's evolving. It's going from being a simple retrieval tool into the essential reasoning brain that connects our AI to the world of private, meaningful data. It's the piece of the puzzle that makes AI not just knowledgeable, but truly intelligent.